Hello everyone. In this video lecture, let us discuss more about performance. So we have seen in the first video lecture regarding the basics of the aircraft performance. So this is the second lecture of the aircraft performance. So in this video lecture, we will discuss about the stalling velocity. So means, and also we will see what is how to achieve the stalling velocity and stalling velocity is being achieved with the help of few parameters. Let us see the equation. Uh, the equation says CL, that means lift equal to, we know, half rho CL into half rho V square S. So in steady level flight, we know in steady level flight, we know lift equal to W, that means lift equal to weight. So by using this condition, we can just rewrite is equal to CL of rho V square S. So now we can rearrange this equation. So V square equal to of, that means it will come 2 W by S whole divided by rho into CL. Then this further can be written V equal to square root of 2 W by S by rho CL. Okay, so this is the velocity, sorry, this is the equation for finding the velocity. So, and in this we know W by S is nothing but load, okay, wing loading, and then rho is nothing but density, and CL is the lift coefficient. So in the wing loading, suppose if the, or what we can say, how to modify this velocity, or how to increase or decrease the velocity. So first thing is, if you want to go for the higher velocity or maximum velocity, so this is what, okay, so for increasing the velocity, either we have to decrease this component or we have to increase this component. So that is how we can go for the maximum velocity. So otherwise what we can say, so as we are, if we want to go for a higher and higher velocity, so we are increasing the wing loading, so indirectly we are increasing the mass of the aircraft or weight of the aircraft, or we have to increase the this one, or we have to decrease the area of the wing. So that is one thing. Or another way, we can just go for increasing or decreasing these two values. So that is how we can go for increasing the maximum velocity. So for decreasing or to achieve the minimum velocity, what we can do, so to achieve minimum velocity, so we can just do certain things. That means one thing is decreasing the wing loading, that means decreasing the wing loading, or we can say increasing the area of the wing. So decreasing the wing loading or increasing the area of the wing. So that is one thing. Or decreasing the wing loading W by S, or increasing the wing area. So that is nothing but S. Or we can decrease the mass of the aircraft. Decrease the mass of aircraft. So this is how we can this is one way of achieving the minimum velocity. That means we can either decreasing the wing loading, or we can increase the wing area, or decrease the mass of the aircraft. Then second way is density cannot be changed anything. So because it is with respect to the altitude, then this CL can be increased by increasing the CL. By increasing the CL, we can decrease the velocity. So this is another way. So one way is this is first point, then second point is this way. So by increasing the CL, we will be able to achieve the minimum velocity. So that means we can decrease the velocity. So minimum velocity means it is the lowest velocity we can say. So minimum velocity means, so by increasing the CL, so for decreasing the or to achieve the minimum velocity, then the CL has to be maximum. So that is the idea. So that means decreasing the by decreasing the minimum velocity, just we are increasing the CL. So this is, we can we are just decreasing and then we are increasing the CL. So minimum velocity means it is the lowest velocity. Minimum velocity is nothing but it is the lowest velocity. So lowest velocity, how can be achieved? So lowest velocity is nothing but lowest velocity is achieved with the help of by this. That means lowest velocity is achieved with the help of increasing the CL, means maximum CL. That means CL, we are increasing, by increasing the CL, velocity is decreased. So by achieve the lowest velocity, CL should be maximum. So CL, if the CL is maximum, that is the lowest velocity. So it means, what is the lowest velocity? Lowest velocity, what we say, lowest velocity is nothing but stalling velocity. So lowest velocity is nothing but stalling velocity. It means, so CL maximum, whenever we are achieving the CL maximum, it means stalling condition is achieved. That is what we say in one way. So and so for achieving the lowest velocity, then CL should be maximum, and then that is how we are reaching the stalling velocity. So here we can just say CL is reached maximum. If the CL is reached maximum, velocity will be minimum. That velocity will minimum velocity, we just say minimum velocity, we say minimum velocity, or we can say stalling velocity. We stall, minimum velocity or we stall. So this is what we can say. It means, So CL maximum, another way we have to analyze CL maximum or lift can be lift can be maximum only when the drag is minimum. So if the drag is minimum, then at that condition only CL can be maximum. So CL maximum is another way is achieved when the drag is minimum. So and one more thing we can say, stalling velocity is the lowest velocity at which the aircraft can sustain in the air. Below this velocity, aircraft cannot sustain in the air. That is what we have to understand. Stalling velocity is the lowest velocity at which the aircraft can sustain in the air, below which the aircraft cannot sustain. So that is what first thing we have to understand. Second thing is CL maximum is achieved when the drag is minimum. So CL maximum can be found out when the or we can say when the drag is minimum.